Today we're going to talk a little bit about my Grand Design Reflection 303 RLS. This is a 2022 model with a build date of November 2021. The inverter prep circuit on this 303 RLS is actually relatively simple. It works something like this. So we have our 50 amp circuit breakers that feed a couple of different bus bars. It feeds one bus bar that includes this 30 amp breaker. From this 30 amp breaker, we go out through the orange Romex that essentially just forms a loop. That Romex goes out to the front bay in the trailer. Just loops back, and we'll take a look at that a little bit. This 30 amp breaker in turn services a bus bar that all of our outlets are connected to. So if we go back and look at what everything is connected to, you can see the two 30 amp breakers say inverter prep. The first 15 amp breaker to the right of that says microwave. Second one says general. And the third one is all the GFCI circuits. So give me a minute. What I'm going to do is pull out these breakers, and then we'll take a look at the different bus bars and kind of give you a better idea. Before we do that though, I want to talk a little bit about electrical safety. So anytime I am messing with this, so I'm going to turn off the power coming into the trailer, and then I'm going to use this little guy. So right now the power is live. So let me just give you an idea how this works. So anytime this guy gets near any AC power, you're going to hear it do this. All right, notice it wouldn't be a good tool for trying to identify a specific circuit, because all I have to do is get it close to the power. But once I turn the power off, I'm going to use that and a couple other methods just to determine that it's safe to work on this. Okay, so I've unplugged the power that feeds the RV. So again, I can go back to my tester, and now I have no current flowing through any of these. Okay, so with the breakers removed, let's go back over what we had. So this terminal, notice this bus bar ends right here. Kind of hard to see. So this is the bus bar, and this is where that 30 amp breaker that goes out to the front on that orange Romex, it plugs in right here. Now if you look carefully, this bus bar is actually, there's no connection between here and here. So essentially, an 120 volt circuit powers the 30 amp circuit breaker through here. It then goes out to the front of the trailer on that orange Romex and comes back into this second 30 amp breaker that plugs in right here. So basically what we're doing with that Romex is essentially jumping from here to here using two 30 amp breakers. So now with the power coming back, we're feeding this bus bar. So we have our two 15 amp circuit breakers that plug in here, and then our GFCI circuit breaker that plugs in here. So you can see the white wires coming in are neutral wires. So everything that's plugged in to this neutral bus bar is actually coming from this side of the circuit. We have our main wire coming in from the pedestal, which supplies all of our neutral lines to our air conditioners and the fireplace. Over here we have a completely separate neutral bus bar So again, what we're doing through this inverter prep circuit is we're taking one of the neutral wires, we're going out through that Romex cable to the front of the trailer, coming back, and we're supplying our neutral for everything that's on the inverter prep side. The ground is a little bit different. You can see the ground bus bar on the back. So ground wise, we always want to keep everything that we can connected to a ground. Remember, that's a safety circuit. The one thing I did notice, and I'm thinking that they did this just to make it easier, but when we talk about this neutral bus bar, this bus bar is coming from our inverter prep circuit. But if you'll notice, let me get my little pointer out here, that, let me see if I can get my pointer up in there and see it. That right there is the back side of the outlet that feeds power to our converter. So if you notice, this wire right here goes up to that outlet, and it's on the neutral bus bar for the inverter prep circuit. So as it sits right now, because this bus bar is disconnected, with the wires cut on the front of the trailer, I will not have a neutral line going to my converter. I think the correct way for them to have done it would have been to bring that wire over to here, but since that outlet has such a short wire, I think that's the reason they went there. So in the front compartment of the trailer, you can see that this conduit coming in says inverter prep, and it comes in through the floor. I'm going to push this down here. So it just essentially loops from the panel inside the trailer up to this front compartment, and then goes back to that second 30 amp breaker. So if I take my tester, this wire is currently live. So what I'm going to do, I'm going to walk around and I'm going to turn off the 30 amp breaker that's coming back from that loop in the front. And I want you to notice what happens. So now when I take my tester, so this wire is still live. Back to my two 30 amp inverter prep. If I turn this one on and turn this one off, now this circuit is completely dead. So by turning this breaker off, cutting the power here, so when I test it up in the front of the RV, there's nothing there. With this breaker, when I turned it off, I still have power through this circuit breaker, out through the Romex, to the front of the trailer, and it comes back, and the power actually stops right here because it can't go through this breaker when it's turned off. So one thing to keep in mind when we're doing this is this breaker controls all of the voltage going out to the front, coming back up until the point where it hits this breaker. This breaker takes the 120 volts that's coming into it and feeds all of our outlets inside the trailer. All right, so back in the front compartment of the trailer, what I'm going to do is actually get ready to install my automatic transfer switch. So Grand Design's instructions tell me to cut this Romex. Of course, I want to make sure that the power is turned off, and then I can determine which side of this wire is connected to that first 30 amp breaker and which side is connected to that second 30 amp breaker by powering the circuit back up and testing to see which one is hot. Then I'm going to take my cable cutter cut the wire. Alright, so after I cut the orange Romex, I just went ahead and stripped both sides back and crimped some connectors on there just to make it a little bit easier to get my probes in there. Trying to do this one-handed is a little bit difficult. So let's start with this side over here. So if I connect my multimeter, you can see it shows about 1.8 volts. So what that tells me is that this wire is now connected to that second circuit breaker, and that this wire I would expect to see 120 volts on. And there you go, 124.5 volts. So this wire is connected to that first 30 amp circuit breaker inside the panel. Originally it was looping the power back to that second 30 amp circuit breaker. So this wire, because it doesn't have any voltage on it, is connected to that second 30 amp circuit breaker. Let's talk about a little bit about automatic transfer switches. So the one that I'm going with on my build is from Progressive Dynamics. It's their 5100 series, which is a 30 amp automatic transfer switch. If we look at their wiring diagram, we can see that these two would go out to our panel. So the hot side, neutral side to the panel. And then the way that they recommend you wire it if you're using a generator is to connect your generator hot to here, your generator neutral to here, and then your shore power hot here, and your shore power neutral here. So what that does, when you're plugged into shore power, the power goes straight through the contacts into your panel. And the relay would not be engaged. When you connect to generator power, there's a delay, so there's a little board sits down here that creates about a 20 or 30 second delay. So as soon as you connect relay power and wait for that delay period, the relay energizes, the contacts switch over, and then your generator power goes up to the panel. Since I'll be connecting this to an inverter and not a generator, I'm going to hook it up a little bit differently, and I'll show you why. What I've done to demonstrate how this automatic transfer switch works is I've connected two power plugs. You can see one there. The one that has the yellow connector actually goes through, it's this wire right here, and you can see it's connected to the terminals that on their instructions say would go or come from generator power. I have a second plug that has, just to tell the difference, this one has the silver metallic jacket on the plug, the other one is the yellow. So the metal jacket, we can follow these lines, comes in and plugs into the automatic transfer switch on this side, which according to the instructions would be coming from our power cord. So we're going to call the metal one the power cord. We're going to call the yellow one generator, so that we can stay with the same standards as their instructions. So generator hot and neutral, and then power cord hot and neutral. So then the output, where it shows two panel, I've connected to that light. So I'm going to plug in the one that says power cord, and you can see that my light lights instantly. The reason for that is that circuit, I'm going to go back to this, the power cord circuit goes straight through the contacts to the panel and doesn't require that the relay energize. Now I'm going to plug in, now remember, I'm going to leave my cord my supply from the pedestal plugged in, and I'm going to plug in the cord that would come from a generator. So there's about a 30-second delay. So you'll see, or you'll actually hear the switch trigger, and you'll see the light flash. Alright, so what that did is we're now powering that light from the generator side, and we're no longer using the one that says power cord. So to prove that, I can unplug the power cord. So if I plug my power cord back in, there shouldn't be any change, because the way this relay is set up is it's going to make the generator side of it the priority. So anytime the generator side is plugged in, the relay is going to stay energized, and it will be this circuit that powers our load. So I'm going to unplug the generator wire, and you'll hear the relay click, and you'll see the light flicker for just a second. So that, now I disconnected the generator, and we're powered from the one that goes to shore power. Alright, there's a couple of reasons that when running from an inverter I'm not going to do that. The main reason is this line right here is the normal state of that relay. So if you'll notice, if I unplug this line, the relay doesn't click. You don't hear anything, but obviously the power goes out. When I plug this line back in, the light immediately comes on, and again, nothing from the relay. So what that tells me is that the normal state is power coming from this cord right here, going directly to the output or the panel. So there's no draw whatsoever, because that's the normal state for that relay. When running from your inverter, you really don't want that relay energized, because that means anytime you're drawing power from your inverter, it's got to send, and it's not a large current, it's just a small current to keep that relay energized. But I would rather have that relay stay energized when I'm operating off of shore power and not from my inverter, just to keep from drawing my battery down. So when I install this, I'm going to connect the line that is marked generator. That is going to be my shore power. So when I plug into shore power, it's going to go through that 30-second delay, and then that relay is going to stay energized. So whenever I'm plugged into shore power, that relay will stay energized. And there was the changeover. So if I make this my inverter side, so again, I'm going to plug my inverter into where they're saying the hot line. That'll do a couple of things for me. So as long as I'm stayed plugged into shore power, I can plug my inverter in, and that contactor doesn't change state. It will still continue to draw power from my shore power. So anytime I'm plugged into shore power, I can leave my inverter plugged in, turned on, and not be drawing from the inverter, but rather from shore power. If I were to set this up the way they show here, where my generator is the primary power, if I plug my inverter into there, anytime I'm connected to shore power, the primary is still going to be the generator, so I'm going to be operating from my inverter. So my automatic transfer switch hooked up with the inverter connected to the shore power, and my shore power connected to where it says generator is going to make shore power my primary. It'll make my inverter my secondary power source. So with this being my shore power, as soon as I disconnect from shore power, my inverter will kick in. This automatic transfer switch comes with a time delay board. So there's a set of pins right there that the instruction manual talks about the time delay circuit. So if I put a jumper on these 2 pins like that, what I'm doing is disabling the time delay circuit on this board. So let me go back and just kind of lay this over here and try not to short anything out. So my time delay circuit was on the one that goes to the generator, which in this case is my yellow plug. So notice now as soon as I plug it in, you can hear that relay energize. The switch changes positions, and within just a couple of milliseconds I have power. It doesn't change the power cord side. The light immediately comes on. The reason for this time delay circuit, if you're operating with the generator, is to give that generator 20 or 30 seconds to power up, stabilize a little bit, and start to warm up before you engage a load. With an inverter, it really doesn't make any difference because your 12-volt supply is already at the inverter and it's ready to power up that load whenever you want to. The only advantage I can see for disabling the time delay circuit is that's just potentially something that down the road could fail. So I'm going to leave this jumper on and get rid of that time delay so that as soon as I lose shore power, again within just a couple of milliseconds, my transfer switch is going to automatically change from shore power over to inverter power. Alright, so with that time delay circuit disabled, I put everything back together. So now let me walk through how this is going to actually be connected in my 303 RLS. So again, instead of shore power, this is going to be my inverter power, and instead of generator power, this is going to be my shore power. So the automatic transfer switch effectively isolates both the positive sides, the hot sides of our circuit, and the neutral sides. The only thing that stays tied together would be your ground wires. So with the automatic transfer switch temporarily mounted, the final resting place will be somewhere different. So I didn't want to cut off any of the Romex until I figure out where that's going to be. But if you remember, this top wire was coming from our panel with the 30 amp 120 volt circuit. It's tied into the circuit that they call for the generator. So that will be our power cord coming in basically. And then this bottom line was the one that goes back out to that second 30 amp breaker, and it ties into the terminals up here at the end, or if we go back to our panel, it says 2 panel. So essentially the power is coming in on this wire, going through this transfer switch, going back out on this wire to our panel. while the final version of my install will have the inverter connected hardwired, I went ahead and put this plug on to represent my inverter, and I'll check the circuits on the inside, make sure that I'm disconnected from shore power, and we'll see if everything works the way I expect it to. Disconnected from shore power with an extension cord running to what would be the inverter side of my automatic transfer switch. You can see that this GFC outlet in the kitchen area has power. The microwave has power. It has power. The TV has power. If I go down and try and turn on the fireplace, it has no power. So, it appears to work like it's supposed to.